Hi everybody. We're going to continue our conversation exploring parabolas. I wanted to review again the horizontal directrix. So I talked about how there's a relationship between a point that called the focus that lies within a parabola, the cup of the parabola, and the directrix which lies below the parabola, or if the parabola is on its side, it is behind or where the vertex of the graph would be. Okay. The thing is, between the focus and the directrix, the vertex sits of the parabola sits exactly between the two pieces. So if this were the focus point was 0, 3, and I know that my vertex, why it's doing that, sorry. I know my vertex is 0, 0, then my, the point at my directrix would have to be at -3, where y equals -3. You notice I said the focus is 0, p for a label, and 0, 3 is the point on this particular graph. If you look down at the directrix, y is equal to the opposite of p. Whatever p is, I take the opposite, so it makes sense that y equals -3 is where the directrix will run through. If you had to write the equation of a line, write the equation of the parabola that had this setup where the directrix was below it and the focus was above it, and it's running through 0, 0, though it's not limited to that. The equation you would use, actually there's two equations, right? We can use this one because we like the function equation. Y over 4p times x squared, or you could use the equation x squared equals 4 times p times y. Okay, let's take a minute and maybe do a practice problem. Okay, so I wanted to show you a quick example of a problem where you're given the focus and you need to figure out the equation of the parabola. So we're told that the focus is at 0, 5 and the vertex of the graph is at 0, 0. So this is how it would look. The graph would be drawn through 0, 0 and the focus would be on the y-axis right up above the vertex. So where would our directrix be? Well, if the focus is at 0, 5, then I told you earlier that your directrix is actually at 0, the opposite of p. If these are 0p, then this is the opposite of p. So the directrix is actually going to be at y equals -5. Okay, so to write the graph of this equation, we're going to use the formula that is y equals 1 over 4p times x squared. So I want you to remember that you know, when this is a parabola that's opening up, that x squared would be the part of the equation. I'm sorry, x would be the letter that would be squared in the equation. So we're going to plug in p here to make our equation. So y equals 1 over 4 times the 5, which is your p in your focus, times x squared. And your final equation for the parabola is y equals 1/20 x squared. This is my equation. Okay, I'm afraid I'm having a little trouble with my stylus, so I'm going to try to finish this last problem. And this is for when you have a vertical directrix. There it goes again. So here we have a problem where the focus is at 3, 0. Notice this is not 0p, it is now p0. And the vertex is at 0, 0 as the others had been. And this is at x equals -3. This is at 3, 0. Sorry, I put the p0 in there to show you that the p has moved in the coordinate pairs because you are looking at a graph that is in a vertical, that has a vertical directrix, so the graph is on right or left-sided opening. So the equation changes for this one, and that is it becomes y over 4p times, x, oh my goodness, x equals 1 over 4p y squared, as opposed to the one we used for the horizontal directrix, which was y equals 1 over 4p times x squared. So they have flip-flopped in position, and as the graphs have flip-flopped in position, as you notice, it's on its side now. So I'm going to take the p-value, which is the 3, and I'm going to substitute it in to this equation, 1 over 4 times 3 y squared. The equation for this graph that is on its side is 1 over 12 y squared. X equals 1 over 12 y squared. So this is just a quick little sketch to remind you that regardless of the direction that the graphs open, and I'm sorry, these are really very sloppy graphs, but regardless of the direction they open, that the parabola's vertex and trying to switch this for another color. The vertex here and the focus are always in line with each other. Okay, they are always in line with each other. As a matter of fact, there is an axis of symmetry that runs through them, and it's not always the axis that does that. So the last thing to remember about the directrix is, for the horizontal directrix, the equation y equals 1 over 4p times x squared can also be written as x squared equals 4 times p times y. Just depends on what you need the equation to say, which variable needs to be isolated. For the vertical, it's actually flip-flopped, right? X equals 1 over 4p times y squared, or y squared equals 4 times p times x. Okay, I also wanted to do a quick review of using the vertex form of the quadratic. I'm trying to put a little 2 up here. This y equals a times the difference of x and h squared plus k. So in your packet number 5, problem number 5C has this particular problem, and I thought I would go over it because it actually lets us use this equation twice, and then we have to dip into our tool bag and pull out our systems of equations. So the first thing we see is there's an axis of symmetry at x equals -2. That means the graph, the vertex, is somewhere on -2, right? X equals -2. So we need to, it's really not going to help us because we don't know the exact point. So it gives us an h but not a k value. So we're going to use that to our advantage and say, because of this, we can at least plug in the h. So I'm sorry, this keeps goofing up. Y equals a times x minus 2. Actually, let me change that to plus 2, right? Because that's a negative 2 over there. Squared plus k. Okay, now we're going to solve this equation by using each of these 2 points and getting 2 more values. Okay, so y equals, I'm sorry, I'm going to use the first one, 1 and negative 4. So 4 equals a times negative 1 plus 2 squared plus k. And then this leaves us with 4 equals, this ends up being, this term here ends up being 1. So a plus k. That was easy enough, huh? And then the other one is using 13. So I'm going to say 13 equals a times 0 is my x value, plus 2 squared plus k. I get 13 equals 4a, right? Because that's 2 squared. So 4a plus k. So now we still need to find a value for a and k. So we're going to use a system of equations. We have 2 equations here that are in terms of a and k. So I am going to write 13 equals 4a plus k, and I'm going to subtract 4 equals negative a minus k, right? I'm going to multiply all of my terms in the second equation by negative 1 to make it cancel out, or I'm subtracting them, right? So this is 9 equals, these are going to cancel, right? Which is the whole point, 3a. So a is equal to 3, and when I plug that back in to 4 equals 3 plus k, then I get k equals 1. All right. So now I have an a and a k, and I had an h up here. So I'm going to write the final equation. Y equals 3x plus 2 squared plus 1. So I want you to remember that when a problem asks you to write an equation, you have to put x and y back in there. These guys have to be there for this to be the equation of a function. All right, I think that's enough for tonight. I will talk to you soon. Email me if you have any questions.